Hello, and thank you for joining me on this gentle journey. Tonight, we will slowly drift into the story of the Mediterranean Sea, tracing its vast sunken basin that once lay dry and desolate across the earth. Imagine the immense tectonic forces shaping the land and sudden floods carving the first waters into life, giving rise to one of the planet's most storied seas. We will glide through time, feeling the gentle currents and exploring hidden depths, from the dramatic Messinian Salinity Crisis to the sudden Zanclean Flood, witnessing how life and civilizations emerged along its shores. If you enjoy these relaxing moments, please consider leaving a like, subscribing, and turning on all notifications so you don't miss any future journeys. But for now, just breathe. Let your body relax, release any tension, and allow your mind to drift. Let's begin. Long before waves shimmered across the Mediterranean, the Earth held a vast, sunken expanse, a basin stretching across continents, its dry valleys etched deep into the crust. The Miocene epoch was a time of patient upheaval. Tectonic forces, subtle yet inexorable, pressed against the land, lifting some ranges while folding and sinking others. In this empty depression, dust storms swept across cracked plains, carrying fine particles from distant deserts that settled in layers upon the parched soil. The sun, low and shimmering on the horizon, cast elongated shadows over jagged ridges, revealing a landscape both desolate and monumental. Mountains rose like silent guardians, their rocky spines outlining the basin, while cliffs formed natural boundaries, hinting at the contours that would one day cradle vast bodies of water. Time seemed to stretch, each millennium folding into the next, while the Earth's crust creaked and shifted imperceptibly, leaving traces of the immense pressures that had been shaping this world long before life could thrive here. Beneath this still expanse, the early frameworks of underwater ridges lay hidden, their presence unnoticed but vital. Channels and depressions, carved by eons of slow movement, presaged the flow of future currents, forming natural corridors that would guide the waters once they returned. The basin's floor was a mosaic of dry valleys and gentle hollows, punctuated by ancient fault lines that whispered of tectonic energy beneath the surface. Even as the land appeared lifeless, it held the memory of potential, a promise that one day the basin would become a living seascape. Dust-laden winds painted fleeting patterns in the air, while occasional rains, rare and scattered, pooled in temporary hollows, reflecting the sky in miniature mirrors that shimmered across the barren terrain. These ephemeral reflections suggested the basin's capacity to one day embrace water, to become a cradle of ecosystems and human civilizations. As millennia passed, the slow movements of the Earth began to reshape the basin in ways both subtle and profound. Valleys deepened, and mountain ranges continued their patient ascent, while subterranean pressures gradually bent and lifted the surrounding crust. Every fold in the landscape, every jagged cliff, hinted at the tectonic history that lay beneath, revealing the forces that would soon collide with oceanic influx to transform this arid expanse. Shadows lengthened across the basin floor as the day wore on, highlighting depressions that would one day form hidden marine channels, guiding currents and life itself. Even in the absence of water, life's potential lingered in the soil, in microbial communities that survived in isolated pockets, hinting at the complex ecosystems that would eventually take root when the basin was inundated. In the distance, the horizons seemed to pulse with anticipation. Ancient ridges and folds suggested patterns that would later dictate the sea's rhythm, guiding both tides and currents when the waters finally arrived. The landscape's stillness was profound, yet it vibrated with latent energy, the promise of transformation, of water reclaiming its place, of life establishing itself in the contours carved by tectonic patience. Dust swirled in lazy eddies, sunlight glinting off mineral veins, giving the impression of a silent symphony, a slow choreography performed by rock and wind over millions of years. In this early epoch, the Mediterranean basin was more than a depression. It was a stage awaiting the entrance of water, a vast amphitheater of stone and sediment, shaped by the patient hand of the earth itself. The mountains, ridges, and valleys spoke of geological forces beyond imagination, laying the foundation for floods, marine colonization, and the eventual shaping of civilizations. As the basin waited, poised between emptiness and potential, the first hints of the submerged corridors and underwater landscapes that would guide currents, sediments, and life were already etched into the planet's crust, invisible to the eye, but enduring in the deep memory of the Earth. This was a world defined by contrast, immense stillness broken by the patient, relentless energy of tectonic motion, arid expanses punctuated by sudden winds and fleeting rains, and a land empty of water, yet pregnant with the possibility of the Mediterranean to come. Beneath the surface of time, the sunken basin held its secrets, silently preparing for a transformation that would echo through millions of years, carrying the story of life, water, and civilization into the chapters that would follow. Millions of years after the Mediterranean basin had formed, the Earth entered a period of dramatic transformation, one that would redefine the region in ways both stark and astonishing. Around 6 million years ago, the connection between the Mediterranean and the Atlantic Ocean became severely restricted. Tectonic shifts and uplift along the Strait at Gibraltar effectively closed the gateway, isolating the basin from the replenishing waters of the Atlantic. The balance of inflow and evaporation tipped decisively toward drying, as the hot, arid climate of the late Miocene accelerated water loss. Without a steady supply of ocean currents, rivers flowing into the basin began to empty into a vast, evaporating depression, leaving salt crusts and mineral plains in their wake. The land stretched across thousands of square kilometers, barren and harsh, punctuated by jagged cliffs and deep fissures carved by wind and sudden flash floods. The scene was both alien and mesmerizing, a testament to the extremes of Earth's climate and tectonic forces. Salt, deposited layer upon layer, accumulated at a staggering rate. These deposits, now among the thickest evaporate layers recorded anywhere on Earth, blanketed the former seabed in brilliant white expanses, glimmering under the sun like frozen snow on a desert plain. Deep canyons, previously carved by river channels, now extended far below the surface, revealing a hidden landscape of steep walls and terraced floors, evidence of repeated cycles of flooding and drying. Inland basins transformed into saline lakes, sometimes evaporating entirely, leaving behind intricate mosaics of crystalline patterns. These extreme conditions created inhospitable environments for marine life, isolating small refuges where species clung desperately to survival. Pockets of brackish water, fed by intermittent streams or subterranean springs, became temporary havens, scattered like fragile islands across an otherwise desolate world. climatic pressures and tectonic forces combined to create this striking spectacle. As rainfall dwindled, rivers such as the Nile and the Rhone fed diminished flows into the basin, unable to counter the relentless evaporation. High summer heat intensified salt concentration, forming layers that were several meters thick in some regions, while vast plains reflected sunlight in shimmering waves that stretched to the horizon. The basin's edges, defined by rising mountains and tectonic uplift, cast long shadows across the salt flats, emphasizing the stark contrast between elevated rock and desiccated lowlands. Dust carried by seasonal winds swept across the surface, depositing fine particles from distant lands, gradually covering older salt layers and recording the passage of millennia in subtle gradients of color and texture. During this period, the Mediterranean's ecological complexity collapsed. Fish, mollusks, and other marine species retreated into refugia, small pockets of remaining water that allowed them to persist despite extreme salinity. Some species adapted to hypersaline conditions, but many vanished from the basin entirely, leaving a fossil record that reveals both the intensity of this desiccation and the resilience of life in the face of environmental extremes. Microbial mats thrived in shallow, ephemeral pools, forming early biofilms that contributed to the layered sediments preserved beneath the modern seafloor. Each layer captures a narrative of survival and extinction, encoding the history of one of Earth's most extreme and extraordinary geological episodes. The basin's desiccation also reshaped landscapes in ways that would affect future oceanic patterns. As river valleys cut deeper into the exposed seabed, new channels and terraces formed, sculpting the eventual pathways through which the Mediterranean would later refill. Islands emerged where submerged ridges had previously lain beneath shallow waters, and exposed land created corridors for the dispersal of terrestrial flora and fauna. Sediment fans at river mouths became extensive, documenting the fluctuations of water flow and marking the transition between arid plains and steep escarpments. Geological evidence from this period shows alternating layers of gypsum, halite, and clastic material, each telling the story of episodic flooding, extreme evaporation, and climate oscillation. Viewed in its entirety, the Messinian Salinity Crisis was an event of extraordinary scale. The Mediterranean basin transformed into one of the most extreme environments on Earth, a landscape defined by vast salt plains, dramatic canyons, and isolated pools of life. This chapter underscores the interplay between tectonics, climate, and hydrology, demonstrating how isolation from the Atlantic and prolonged aridity could reshape entire seas. The dramatic contrasts of empty basins and mineral-rich plains foreshadow the explosive reintroduction of water during the Zanclean Flood, setting the stage for the rebirth of marine ecosystems and the gradual return of biodiversity. The narrative arc of desiccation and renewal begins here, revealing the latent forces that would guide both water and life back into this transformed basin, linking geological extremes to the enduring story of the Mediterranean. A monumental shift transformed the Mediterranean landscape as the Pliocene epoch began, heralded by a sudden and spectacular inundation known as the Zanclean Flood. After nearly 6 million years of desiccation, the barrier separating the Atlantic from the Mediterranean finally gave way. Geological pressures, sea level rise, and tectonic activity combined to breach the narrow strait at Gibraltar, allowing the vast waters of the Atlantic Ocean to surge in with incredible force. The flow carved deep channels, gouging new canyons into the formerly exposed seabed and reshaping the contours of the basin with a violence tempered only by geological time. Within months to years, what had been an arid expanse became an immense ocean, and the once scorched plains disappeared beneath roiling, churning waves. Rivers that had once carved into dry sediments now poured into a sea that rose faster than the land could adjust, creating temporary waterfalls and cascades along submerged terraces. Salt flats dissolved, leaving mineral-rich waters that mixed with the incoming Atlantic currents, creating gradients of salinity that would influence marine colonization for millennia. The floodwater scoured the basin floor, deepening valleys and smoothing ridges, while turbulent currents carried enormous volumes of sediment across the newly submerged landscape. Cliffs that had once stood as silent witnesses to the sun-baked plains now reflected sunlight across undulating waves, casting shadows into the forming depths and revealing a complex underwater topography shaped in the blink of geological time. Life began to reclaim the basin almost immediately. Microorganisms, plankton and early invertebrates drifted with the currents, spreading across vast distances, while small fish entered from the Atlantic, establishing the foundations of renewed marine ecosystems. Coral and sponge communities anchored to submerged ridges, forming the first fragile reefs in this revitalized environment. The flood created a mosaic of habitats, from shallow coastal shelves to deep, newly formed trenches, each offering niches for colonization and adaptation. Salinity gradients and varying water temperatures, established by the mixing of Atlantic and residual Mediterranean waters, created conditions for rapid evolutionary experimentation, setting the stage for the diverse marine life that now characterizes the region. The visual spectacle of the flood was extraordinary. Torrents of water surged through narrow straits, plumes of foam and spray rising like miniature clouds along the newly formed coasts. Submerged mountains and ridges guided the flow, producing dramatic channels, whirlpools and eddies that transported nutrients and sediments across the basin. The Atlantic's incursion sculpted underwater landscapes that remain identifiable today. Submerged valleys, terraces and escarpments tell the story of an ocean arriving with unprecedented speed and energy. Sediment deposition was uneven, forming thick layers in some depressions and leaving exposed rocky ridges elsewhere, creating a diverse seabed that would support ecosystems of striking complexity. The refilling of the Mediterranean did not occur uniformly. Localized conditions shaped distinct regions. Coastal areas were inundated first, forming bays, estuaries, and shallow shelves that soon became nurseries for marine life. Deeper basins filled later, allowing currents to develop along natural underwater corridors formed by tectonic uplift. These currents not only redistributed sediments, but also facilitated the spread of species from the Atlantic, creating a dynamic exchange between ecosystems. As water levels stabilized, the sea's chemistry balanced and oxygenated waters penetrated deep basins, supporting invertebrates and vertebrates alike. From a geological perspective, the Zanclean Flood illustrates the power of tectonics and sea level variation acting in concert. It reshaped the Mediterranean, erased the evidence of desiccation from surface landscapes, and prepared the basin for millennia of biological colonization and ecological complexity. The flood also established the connection between ocean circulation and sedimentation that would influence climate patterns, coastal geomorphology, and human settlement for generations. This event stands as a testament to the immense forces capable of rapidly transforming entire ecosystems and landscapes, linking the arid desolation of the Messinian Salinity Crisis to a rejuvenated ocean alive with potential. The Zanclean Flood was more than a geological event. It marked the awakening of the Mediterranean as a living sea. From barren basins to rolling waves teeming with life, the transition embodies both violence and renewal, laying the foundation for ecological networks, sediment dynamics, and the eventual interaction between humans and these waters. The flood's legacy is preserved beneath the surface, in submerged channels, terraces, and ridges, and above it, in the rhythms of currents and the distribution of species that trace their origins to that extraordinary moment when the Atlantic poured its waters into a long, dry basin. The narrative flows seamlessly toward the next stage, the gradual colonization of life and the establishment of enduring marine ecosystems. As the Mediterranean basin filled with the rushing waters of the Zanclean Flood, the stage was set for the emergence of complex life. In the newly submerged landscapes, microscopic plankton drifted along gentle currents, forming the foundation of a recovering food web. These tiny organisms captured sunlight through photosynthesis, releasing oxygen and shaping the chemical balance of the water. Their presence attracted small invertebrates, which grazed on the abundant plankton and gradually established the first visible ecosystems. Coral and sponge communities began to attach to underwater ridges and rocky outcrops, creating the initial structures that would shelter and support increasingly diverse marine populations. Over time, these early reefs expanded, forming a tapestry of habitats in which larger organisms could thrive. Fish and other mobile species soon migrated from the Atlantic through the reopened strait, colonizing the basin in successive waves. Early bony fish explored shallow shelves, while more specialized species adapted to deeper, cooler waters along submerged valleys and trenches. These migrations created dynamic patterns of interaction, competition, and adaptation. Coastal zones became nurseries for juvenile fish, while offshore ridges offered refuge from predators, establishing ecological niches that promoted biodiversity. The interplay of light, salinity, and nutrient flow across different depths and regions contributed to the gradual establishment of a stable but evolving marine network. Vegetation beneath the waves responded to these changes as well. Marine plants, including seagrasses and algae, took root in sheltered coastal areas where sediments had stabilized. Their growth helped reduce erosion and facilitated the deposition of organic material, enriching sediments for future generations of benthic organisms. As photosynthetic activity increased, oxygen levels in the water rose, further supporting the growth of invertebrates, crustaceans, and early mollusks. These interactions formed the first complex, self-sustaining food chains, linking microscopic producers to larger predators in a delicate balance that persisted for millennia. The underwater landscape was sculpted by both biological and geological forces. Currents moved sediments from exposed highlands to lower basins, while tectonic uplift slowly shifted ridges and slopes, creating new habitats for colonization. Coral formations and sponge clusters grew along these elevated structures, producing microenvironments where species could hide, feed, and reproduce. The variation in depth, slope, and water chemistry encouraged diversification as organisms adapted to specific conditions. Soft, sandy plains contrasted with jagged ridges and the gradual accumulation of organic detritus created fertile zones for benthic communities. Together, these features fostered the mosaic of ecosystems that would define the Mediterranean for millions of years. Predatory species began to emerge as food webs became more complex. Small fish and invertebrates were hunted by larger fish, cephalopods and crustaceans, creating dynamic interactions that regulated populations and promoted adaptive evolution. Over time, these pressures encouraged specialization, with certain species evolving unique behaviors, feeding strategies, and physiological adaptations suited to the Mediterranean's varying environments. These early evolutionary experiments laid the groundwork for the biodiversity that characterizes the sea today, demonstrating the direct link between environmental recovery and life's capacity to colonize new frontiers. Seasonal cycles and climate fluctuations further shaped these ecosystems. Periodic influxes of fresh water from rivers influenced salinity levels near coastlines, while deep currents redistributed nutrients across the basin. Marine life responded to these variations by migrating, reproducing, and establishing temporary refuges in sheltered areas. Even small changes in water temperature or nutrient concentration could shift community structures, prompting gradual adjustments in species distribution and abundance. Observing these interactions reveals how environmental factors and biological responses intertwine to create resilient ecosystems capable of withstanding external pressures. By the end of this period, the Mediterranean had transitioned from a recently refilled basin to a thriving marine world. Coral reefs, seagrass beds, and sponge communities spread across underwater ridges and slopes, while mobile species navigated the currents and occupied ecological niches ranging from shallow shelves to deep trenches. The formation of early marine ecosystems illustrates the delicate relationship between physical geography, water, chemistry, and biological adaptation. These networks of life provided the foundation for future evolutionary milestones, creating a living environment that would support complex species and, eventually, human interaction with the sea. The colonization of life in the Mediterranean demonstrates the resilience of ecosystems following extreme geological events. From microscopic plankton to emerging reef communities, each step in this recovery shaped the intricate patterns of biodiversity that define the sea. As sediments settled and currents stabilized, life established an enduring presence, linking the violent reshaping of the basin during the Zanclean Flood with the gradual unfolding of ecological richness that would influence both natural evolution and human history. The narrative now gently moves toward the continued shaping of the Mediterranean by tectonic forces and the emergence of islands and coastlines, connecting biological colonization with geological evolution. As marine life flourished across the newly filled Mediterranean basin, the forces of Earth's crust continued to shape the region in subtle but transformative ways. Tectonic plates along the northern and southern margins of the sea shifted over millions of years, producing a dynamic landscape of rising mountains, submerged ridges, and newly formed islands. These slow movements lifted coastal ranges, creating dramatic cliffs that caught the sunlight and cast elongated shadows across the waters below. Valleys deepened, and underwater troughs and trenches emerged, guiding the flow of currents and influencing sediment deposition throughout the basin. The interplay between land and sea began to dictate patterns of water movement, salinity gradients, and nutrient distribution, providing a physical framework for the flourishing ecosystems already established. Islands emerged where tectonic uplift intersected with volcanic activity, or where fault lines allowed blocks of the crust to rise above the water's surface. Each island presented unique habitats for both terrestrial and marine life. Rocky shorelines contrasted with sheltered coves, and shallow lagoons formed behind barrier ridges, creating nurseries for young fish and invertebrates. Submerged terraces and ridges beneath the waves further diversified habitats, offering refuge and feeding grounds for organisms ranging from plankton to predatory fish. As mountains pressed upward, erosion slowly redistributed sediments, creating deltas at river mouths and expanding the mosaic of environments along the coasts. The formation of these physical features directly influenced water circulation. Narrow straits between emerging islands funneled currents, intensifying flow and mixing waters from different parts of the basin. Shallow shelves warmed under sunlight, while deeper channels remained cooler, establishing thermal layers that guided marine life and influenced nutrient cycling. Periodic seismic activity occasionally altered the seafloor, shifting ridges, opening new basins, and creating submarine cliffs that would become hotspots for colonization. These tectonic changes produced an intricate underwater topography that shaped the patterns of life, migration, and ecological interactions that continue to characterize the Mediterranean. Sediments carried from eroding mountains and river deltas enriched the shallow coastal waters, promoting productivity among plankton and benthic communities. Fine silts and sands settled along gently sloping shelves, while heavier gravels accumulated near cliffs and channels. These deposits recorded episodes of flooding, landslides, and storms, creating a layered history of environmental change. In sheltered bays, sandbars and mudflats developed, offering critical feeding grounds for fish and invertebrates, and supporting early colonization of plant life in brackish zones. Over time, this interplay between tectonic uplift, sediment deposition, and marine currents produced a highly complex and diverse seascape, with habitats ranging from turbulent coastal waters to calm, deep-sea trenches. Volcanism in certain regions further contributed to the sculpting of islands and coastlines. Submarine eruptions built new landmasses that gradually emerged above the waves, while ash and lava enriched surrounding sediments, affecting water chemistry and nutrient availability. Lava flows that reached the sea created intricate underwater formations, providing additional structure for coral and sponge communities to anchor and thrive. These interactions between geologic activity and marine colonization illustrate how dynamic processes beneath the surface directly shaped the biodiversity observed above and below the waves. The emerging coasts and islands also began to influence early patterns of life on land. Birds, small mammals, and coastal vegetation gradually colonized newly formed islands, creating interconnected ecosystems that bridged marine and terrestrial environments. Shifting coastlines dictated the locations of sheltered bays and harbors, which would later play a crucial role in human migration, trade, and settlement. Observing these changes, it becomes evident how geological sculpting provided both opportunities and constraints for life, guiding ecological distribution and evolutionary pathways. Through millions of years, the Mediterranean transformed from a simple flooded basin into a complex network of islands, cliffs, ridges, and trenches. Each geological shift, whether a rising peak, submerged ridge, or newly formed strait, interacted with currents, sediments, and ecosystems, producing a living mosaic that would endure across time. The tectonic shaping of coasts and islands demonstrates the enduring influence of Earth's forces on both marine and terrestrial life, connecting the early colonization of species with the evolving geography that would shape the Mediterranean's ecological and cultural history. The intricate architecture of mountains, islands, and underwater ridges now set the stage for subsequent chapters, where climate fluctuations, currents, and human interactions would further define the sea's character. These enduring formations serve as the silent framework upon which ecosystems and civilizations alike would come to depend, illustrating the profound and continuous relationship between geology and life across the Mediterranean basin. Beneath the sunlit surface of the Mediterranean, the slow ascent of mountains and the emergence of underwater ridges reshaped the basin in profound ways. Along the northern margins, the Apennines, Alps, and Dinaric ranges rose steadily, their peaks catching the light and casting elongated shadows over valleys and coastal plains. On the southern shores, the Atlas and Rif mountains ascended in tandem, sculpting cliffs that tumbled toward the sea. These uplifts created dramatic relief across the region, influencing river courses, sediment deposition, and the formation of sheltered bays and estuaries where marine life could flourish. Submerged ridges extended across the basin floor, guiding currents, establishing deep channels, and delineating ecological boundaries for both pelagic and benthic species. Seafloor mapping reveals a labyrinth of underwater valleys and plateaus, each formed through tectonic uplift and minor subsidence. These structures influence circulation patterns, concentrating nutrient-rich waters in specific areas, while allowing other regions to remain relatively stable. Currents flowing over ridges churn sediments into the surrounding basins, forming gentle fans that sustain microorganisms at the foundation of the marine food web. Sunlight filtering through the water highlights these features, casting soft, shifting patterns over the seabed and illuminating the delicate interactions between topography and life. As mountains rose and underwater ridges expanded, the distribution of marine habitats diversified. Rocky slopes and deep trenches provided refuge for invertebrates, while shallow platforms encouraged the growth of corals and sponges. Fish populations adapted to these varying conditions, establishing complex migration corridors between shallow bays and deeper waters. Sediment accumulation along ridges created temporary barriers and pockets, supporting localized blooms of plankton and forming essential feeding grounds for larger species. The combination of elevated peaks above water and ridges below created a three-dimensional seascape that enhanced both biodiversity and ecosystem resilience. Tectonic uplift also influenced hydrology on land, directing rivers toward the sea and producing deltas rich in nutrients. Seasonal flows deposited layers of silt and clay, which would later be redistributed by tides and currents. These sediments nurtured shallow coastal ecosystems, promoting the establishment of seagrass beds and intertidal habitats. In contrast, deeper trenches and submarine canyons remained, largely inaccessible to light, hosting species adapted to low-light conditions and slow-moving nutrient flux. Together, these variations created a mosaic of environments shaped by the interplay of tectonics, water, and biological colonization. Volcanic activity in certain areas contributed to this intricate architecture, building islands and underwater cones that further disrupted currents and sediment paths. Lava flows that met the sea formed unique substrates for early benthic communities, while isolated islands provided breeding grounds for seabirds and coastal vegetation. Over millennia, the combination of tectonic uplift, ridge formation, and volcanic activity produced a Mediterranean basin of remarkable complexity, linking geological forces directly to ecological patterns. These rising mountains and underwater ridges established the framework that would govern currents, nutrient distribution, and habitat diversity for millions of years. Their presence dictated migration pathways for marine life and shaped the coasts where humans would later settle. The evolving terrain illustrates the profound influence of Earth's crust on the Mediterranean's character, demonstrating how the slow movement of land and sea forged an intricate and enduring environment. Beneath the shimmering surface of the Mediterranean, layers of sediment accumulated over millions of years, silently recording the basin's extraordinary history. Fine silts carried by rivers settled along shallow shelves, while heavier sands and gravels tumbled into deep channels and canyons, building intricate underwater landscapes. Each stratum preserves clues to past events, eruptions, floods, and shifts in sea level, allowing scientists to reconstruct epochs long vanished from sight. Fossilized shells, microfossils, and mineral deposits embedded within these sediments tell the tale of evolving climates, shifting currents, and the gradual colonization of marine life. Cores extracted from the seafloor reveal alternating bands of organic material and mineral layers, marking cycles of abundance and scarcity. The Messinian Salinity Crisis, for instance, left thick deposits of evaporate salts, remnants of a basin once nearly devoid of water. Later layers bear the imprint of the Zanclean Flood, a sudden influx that refilled the basin, scouring older sediments and redistributing nutrients across the sea floor. These sedimentary records offer more than geological data. They map the interaction between tectonic activity and oceanography, showing how uplifted ridges redirected currents and guided the deposition of materials over vast distances. Subtle variations in sediment composition reveal the influences of distant deserts, windborne dust, and volcanic ash, highlighting the Mediterranean's role as a crossroads of climatic and geological forces. Gentle underwater slopes showcase the layering of these deposits, forming fans and terraces where plankton and benthic organisms found nourishment and shelter. Over time, these accumulations shaped the contours of the seafloor, creating microhabitats that would support the emergence of complex food webs and diverse ecological niches. By reading the Sedimentary archive, we can observe the dynamic balance between erosion, deposition, and marine life. Each layer captures a moment of transformation, linking geological upheaval to the gradual flourishing of ecosystems above. Through this slow accumulation, the Mediterranean holds a detailed narrative of environmental change, revealing how ancient events continue to influence modern currents, biodiversity, and coastal landscapes. Beneath the sun-dappled surface, the Mediterranean's waters began to move in intricate, interwoven patterns, forming the complex currents that would govern the basin's ecology and climate for millennia. As the Atlantic poured in through the Strait of Gibraltar, dense, salty water cascaded into the deeper regions, while lighter, fresher, surface waters flowed outward, establishing a delicate vertical circulation. These movements distributed heat and nutrients throughout the basin, creating stratified layers where temperature, salinity, and oxygen levels varied with depth. Submarine ridges and trenches guided the flow, concentrating turbulence in some areas while allowing calmer pockets to emerge, fostering diverse habitats for marine life from plankton to deep-sea fish. Seasonal winds above the surface, particularly the Mistral and Sirocco, reinforced the motion of the water, generating eddies that mixed the upper layers and influenced surface productivity. These wind-driven currents delivered nutrients from rivers and coastal runoff into open waters, nourishing plankton blooms that formed the foundation of the food web. Beneath the surface, deep currents carved subtle channels through sediment deposits, slowly redistributing materials across the basin floor. By observing these flows, we gain insight into how energy moves through the sea, shaping both its physical and biological structures. Long-term climate shifts played a decisive role in modulating circulation. During cooler periods, increased density gradients intensified the sinking of saline water in the eastern Mediterranean, reinforcing the flow toward deeper basins. Warmer epochs altered stratification, allowing surface waters to linger and slow the exchange with the Atlantic. Over thousands of years, these changes influenced the migration of species, the growth of plankton populations, and the deposition of sediments along continental shelves. Even minor variations in water temperature and salinity reverberated through the ecosystem, affecting food availability and reproductive cycles. Topographical features such as underwater mountains, submerged valleys, and coastal promontories interacted with these currents, forming intricate networks of eddies and upwellings. Nutrients carried by deep water flows nourished hidden reefs, while suspended sediments created transient habitats for microscopic organisms. Coastal currents, in turn, shaped the development of estuaries, deltas, and shallow bays, influencing where early human populations would find sustenance and navigable waters. These flows not only dictated ecological patterns, but also left enduring marks on the physical landscape, carving channels and redistributing sediments in ways that continue to define the basin today. By understanding the interplay between water movement and climate, we see how the Mediterranean evolved into a living system of interdependent currents, habitats, and microclimates. The rhythmic motion of the sea, invisible yet potent, orchestrated the distribution of nutrients, the migration of species, and the formation of ecosystems. These deep water flows reveal the hidden architecture of the basin, connecting geological history with the life it sustains, and foreshadowing the challenges and transformations that modern climate change may impose on this timeless sea. From the earliest moments when humans first encountered its shores, the Mediterranean Sea has been a catalyst for culture, trade, and exploration. Coastal valleys and natural harbors provided ideal settlements for small fishing communities, where people relied on the abundance of fish, mollusks, and seaweed for sustenance. The rhythmic rise and fall of the tides guided their daily lives, while the intricate network of islands and peninsulas offered both refuge and strategic vantage points. Over centuries, these early settlements expanded into towns and, eventually, sprawling civilizations that used the sea not merely as a resource, but as a highway for connection across continents. Maritime knowledge became a defining feature of these societies. By observing wind patterns, currents, and seasonal fluctuations, ancient sailors navigated the narrow straits and open waters, linking communities from the Levant to Iberia and from North Africa to the Italian Peninsula. The Mediterranean became a conduit for goods, including olive oil, wine, grain, and pottery, as well as a vehicle for the exchange of ideas, art, and religious practices. Through this interwoven commerce, distant cultures influenced each other, creating shared traditions and hybridized technologies that would shape the course of history. The geography of the sea dictated human activity. Natural bays and sheltered coves served as hubs for trade and military strategy, while shallow coastal shelves allowed for the development of ports and shipbuilding facilities. Meanwhile, underwater topography influenced the flow of currents and the distribution of marine resources, subtly guiding where communities thrived and which routes became primary arteries of commerce. Early civilizations learned to read these waters, interpreting subtle shifts in salinity, temperature, and marine life as indicators of favorable fishing grounds or safe passage. Beyond commerce, the Mediterranean played a role in cultural and intellectual development. Coastal regions became centers of learning, art, and religion, with the sea inspiring myths, stories, and cosmologies that reflected the interplay between humans and the natural world. Harbors and city-states such as Carthage, Athens, and Alexandria grew into hubs of political and economic influence, each drawing upon the bounty of the sea to sustain urban populations and fund architectural and scholarly endeavors. Trade routes connected these urban centers to distant territories, spreading not only material goods, but also knowledge and innovation, allowing civilization to flourish in tandem with the rhythms of the ocean. Environmental challenges also shaped human interaction with the sea. Variations in climate and water levels, along with tectonic activity, influenced settlement patterns, agricultural strategies, and maritime navigation. The need to adapt to rising or falling shorelines, storms, and shifts in currents honed both technology and observation, pushing humans to develop resilient practices and engineering feats. Salt production, aquaculture, and harbor construction emerged in response to environmental pressures, revealing a profound understanding of the delicate balance between human ambition and natural forces. Through these centuries, the Mediterranean remained a dynamic and living entity in human consciousness. Its waters nourished civilizations, shaped political boundaries, and inspired enduring works of art and literature. The influence of the sea extended far beyond its physical presence, guiding societal development and connecting peoples across vast distances. By observing the interplay of geography, currents, resources, and human ingenuity, we gain insight into how the Mediterranean became not only a cradle of culture and commerce, but also a reflection of humanity's capacity to adapt and thrive alongside the ever-changing rhythms of the natural world. The Mediterranean Sea stands at the threshold of a new epoch, its future intricately linked to climate fluctuations, tectonic activity, and human influence. Rising global temperatures are already altering the balance between evaporation and precipitation, creating subtle shifts in salinity that ripple through its ecosystems. In the eastern basin, elevated salt concentrations may increase the density of deep waters, intensifying the vertical circulation and influencing nutrient transport across the basin floor. Conversely, regions receiving greater river discharge could see layers of fresher water linger near the surface, altering habitats and impacting plankton growth. These hydrological variations will shape the distribution of species, the productivity of fisheries, and the resilience of ecosystems that have evolved over millions of years. Coastal regions are particularly vulnerable to sea level changes, driven by thermal expansion and melting ice sheets. Low-lying plains in North Africa, southern Spain, and parts of the Levant could experience gradual inundation, while emergent landforms may disappear beneath slowly encroaching waters. Islands, many of which have been sculpted over millions of years of tectonic uplift and volcanic activity, may undergo subtle shifts in their coastlines, affecting human settlements, wildlife corridors, and the flow of currents along shallow shelves. The intricate interplay of rising seas and shifting topography is likely to redefine maritime geography, creating new bays, estuaries, and submerged valleys that will challenge both natural systems and human infrastructure. Beneath the waves, the Mediterranean's deep-sea habitats face transformations driven by temperature gradients, salinity changes, and nutrient availability. Cold water coral reefs, sponge gardens, and benthic communities may be displaced as thermohaline layers migrate, while species adapted to specific salinity ranges could experience stress, migration, or local extinction. In some areas, new ecological niches may open, allowing opportunistic organisms to colonize previously uninhabitable zones. Submarine canyons and sedimentary fans will continue to capture detritus from land and sea, recording these evolving patterns and serving as long-term archives of environmental change. Tectonic activity adds another layer of complexity to the Mediterranean's future. The collision of the African and Eurasian plates continues to generate uplift in mountain chains, strain along faults, and occasional seismic events. Shifts in crustal structure could alter the bathymetry of the basin, redirect currents, and influence sediment deposition. Over centuries, these movements may create new islands or modify existing ones, shaping pathways for species dispersal and human navigation. Combined with climate-driven changes, the interaction between geology and hydrology presents a dynamic scenario where natural forces continuously redefine the character of the sea. Human influence intersects with these natural transformations in profound ways. Coastal urbanization, industrial activity, and water extraction from rivers influence nutrient loads, chemical composition, and sediment flux into the Mediterranean. Efforts in marine conservation, sustainable fishing, and habitat restoration will play critical roles in determining which species persist and which habitats can endure rising pressures. Observing how civilizations adapt to these changes through engineering, policy, or ecological stewardship offers insight into the balance between human agency and natural rhythms. Looking further into the distant future, projections suggest that the Mediterranean may experience alternating periods of enhanced evaporation and replenishment from Atlantic inflow, reshaping salinity gradients and deep water circulation. Currents may strengthen in some basins and weaken in others, influencing larval transport, fish migration, and carbon sequestration in the deep sea. Coastal ecosystems may see the expansion of wetlands and marshes in some areas, while others experience erosion or submersion. Geological modeling combined with climate science allows a glimpse of these possibilities, highlighting the intricate and evolving tapestry of the sea. Through this lens of change, the Mediterranean story comes full circle. From a desiccated basin to a flood-filled cradle of life, from tectonic upheavals to the rise of civilizations, the sea has continuously responded to forces both sudden and gradual. Its future will continue this tradition of transformation, reflecting the combined influence of climate, geology, and human interaction. By observing these patterns, we gain not only knowledge of potential environmental shifts, but also a sense of reverence for the enduring continuity of this remarkable oceanic landscape, a place where the past, present, and future converge in a rhythm of water, life, and land. As our journey through the Mediterranean Sea comes to a close, allow yourself to sink even deeper into relaxation. Picture the serene waters flowing over ancient coastlines, the soft pulse of currents beneath, and the subtle echoes of tectonic shifts that shaped mountains and deep-sea ridges. Feel your thoughts gently fading as we trace the slow evolution of marine life, civilizations, and the climate that continues to shape this timeless sea. Let the sense of history, hidden depths, and future possibilities envelop your mind and body. Rest here, fully supported in this safe and tranquil space. If you enjoyed this relaxing moment, please consider leaving a like, subscribing, and turning on all notifications so you don't miss future immersive journeys. For now, let your body release tension and your mind drift. Good night and sleep well.